how you doing? We want to do a little something today. Simple harmonic motion from your secondary schools. I know your teacher has told you something like that. I want to show you how to derive displacement of simple harmonic motion. You know, it might be a little tricky sometimes. We just follow us and see how it goes. Thank you. Now look at the cycle A, B, C, and D. You will discover that from B to the center is the radius of the circle. So we're talking about you having a stone tied to the end of a rope, and then you wire it round and round and round, right? Now when you do that, you discover that the length of the rope you have is the radius of the cycle you make each time you wire that rope. Now if that is the case, you will each time you wire cover a distance around the circle, but we want to cut a small portion of the distance around the circle, and then we call it S in this case. Now if you look, you discover that from the beginning B here to this point, all that we call S, there is an angle it suspends, theta. Now this angle it suspends with our S together with this radius, we will try to bring it out of this diagram to make it easier for us to understand. Now, having cut out this portion from our original circle, you would realize that it gives us something similar, exactly what we used to study and we call length of an arc in mathematics. Now, in your mathematics, you have length of an arc, and length of an arc is given by L is equal to theta all over 360 times 2 pi r. Now, if you have this, in the situation we have here, our length of arc is S, because this is the arc we made. So the length of the arc here becomes S. So we can replace this by saying S here is theta all over 360 times 2 pi r. Very simple. Now, if you proceed, in radians, this is in degrees. 360 is a representation in degrees, but in radians, 2 pi is equal to 360 degrees. So here we can now see that what? S is equal to theta all over 360 times 2 pi r. Since 2 pi is equal to 360, then we can now clean our 360 and write 2 pi. And if that is the case, then we can now cancel out. 2 cancels 2, pi cancels pi. And that will give you that S is equal to theta times r. S is equal to theta r. The formula for displacement in simple harmonic motion. Thanks for watching today's episode of Physics Classes with Ode. I hope you enjoyed it. Please subscribe to our channel for more videos. Thank you.